Assalamu alaikum wa rahmatullahi wa barakatuh. This is the 9th video and the last one of chapter 11, Work and Energy. At the end of this video, we're going to talk about the non-conservation of mechanical energy. It's good to remember that we have mentioned in the last video that the mechanical energy is the sum of the kinetic plus the gravitational potential energy. Besides, the work done by the conservative forces is equal to the opposite of the variation of potential energy. If there is no non-conservative force acting on the system, then the mechanical energy is conserved. Thus, delta mechanical energy is 0 joules, or the variation of the kinetic energy is equal to the opposite of the variation in the gravitational potential energy. We still have to talk about the non-conservation of mechanical energy. We have found that the mechanical energy of a system is not conserved if its value varies with time. It may increase or decrease, such that the work done by a non-conservative force results in changing the mechanical energy of the system. Therefore, the variation in the mechanical energy of the system is due to the net work or the sum of the work done by the non-conservative forces. Let's make a kind of verification for this using the work energy theorem, which states that the variation in the kinetic energy equals to the sum of the work done by all forces, which means that it is the sum of the work done by the conservative forces and the work done by the non-conservative forces. We remember that in the previous video we said that the work done by the conservative forces is equal to the negative of the variation of the potential energy. Thus, the relation can be written as delta kinetic energy equals to the sum of the work done by non-conservative forces minus delta potential energy. Finally, we can write it as delta kinetic energy plus delta potential energy equals to the sum of the work done by the non-conservative forces. The delta kinetic plus the delta potential means the delta mechanical energy. Thus, we can write the relation delta mechanical energy equals to the work done by the non-conservative forces. Consider these graphical studies about the non-conservation of mechanical energy. If the sum of the work done by the non-conservative forces is negative, then the mechanical energy decreases in this case. Here we can say that the variation of the gravitational potential energy is exactly opposite to the variation in the kinetic energy. The fact is, the kinetic energy is transferred into gravitational potential energy plus into heat maybe, or any other form that is considered as lost. The case when friction exists maybe. In this case, friction makes some energy be transferred into heat, and then mechanical energy is not constant anymore. It will be decreasing with time. The second example, if the sum of the work done by non-conservative forces is positive, in this case, the mechanical energy increases. If we look to this graph, we can find that the decrease in the gravitational potential energy results in an increase in the kinetic energy. But it seems that the variations are not equal to each other. This is the case when a traction force exists. Then the gravitational potential energy results in the increase in the kinetic energy, but the extra in kinetic energy came from the work done by the traction force as an example. Let's solve this application. Ali is pulling a chariot from rest, a distance AB, such that AB is 10 meters, by applying a force F, making an angle 60 degrees with the horizontal plane. During its motion, the chariot of mass m equals to 15 kilograms is under the action of its weight, friction force of magnitude 20 newtons, a normal force N, and a force F of magnitude 80 newtons. Calculate the work done by the non-conservative forces acting on the chariot. The non-conservative forces here are the friction force, which is a resistive force, and the force of pulling, which is a motive force. The work done by friction is minus FAB, minus 20 times 10, finally minus 200 joules, while the work done by F is FAB cosine alpha, finally it is 400 joules. Deduce the speed of the chariot at position B, taking the horizontal plane passing through A and B as the gravitational potential energy reference. The question is deduce. Then we should use a relation that relates energy with the sum of the work done by non-conservative forces, which is delta mechanical energy equals the sum of the work done by non-conservative forces. This means mechanical energy at B minus mechanical energy at A equals to the work done by F plus the work done by friction. But we know that the gravitational potential energy at A and B is zero since the height is zero. They are on the reference level. Besides, the kinetic energy at A is zero since the motion starts from rest. Finally, we get half m v squared, which is the expression of the kinetic energy, equals to 200 joules, which is 400 minus 200. The answer then, VB equals to 5.16 meters per second. This is the end. Please don't forget that the mechanical energy is the kinetic plus the gravitational potential energy. If the mechanical energy is conserved, then it is constant, and delta kinetic energy equals to the minus delta gravitational potential energy. If there is non-conservative force acting on the system, then the mechanical energy is not conserved, and the variation is the work done by the non-conservative forces. Finally, the mechanical energy may increase or decrease according to the non-conservative forces acting on it. This is the end of part 9. Thank you for watching.